Today we are going to talk more or study or know more about sample machines, work and sample machines. Before we do it, let's apply what did we study last time in this sheet or in this question. First, what converts what into what? Yes, machine, they convert the input force into output force. Why? We use the machine to make the tasks easier for me. Also, they don't change the work needed or required to do the task. They change only the force's direction, size, or distance. So the machines can save my power or can save energy by changing the force's direction, size, and distance, but they do not change the work needed. That's why we said last time the input work equals to the output work done by the machine. Let's remember together the input force, it is the force that you apply on the machine. The output force, it is the force that is applied by the machine. The input work equals the input force multiplying by input direction. The output force, the output work equals the output force multiplying by the output distance, and they equal to each other. So how do machines make the work easier for me? Yes, they convert or change the size of the force that we apply or the distance that we apply or the direction of the force we apply. How can we calculate or get to know how much force the machine changed in my force, in my applied force, in my input force? By calculating something, it's called machine's mechanical advantage. How can we get it? By dividing the output force over the input force, by getting the ratio of the machine's output force to the applied input force. This is how we calculate the mechanical advantage of any machine we use. Sometimes we can find that this mechanical advantage is more than 1 or less than 1 or equal to 1. Why? Because it tells me how many times larger or smaller the output force is than the input force. So if the mechanical advantage is greater than 1, it means that the output force now is greater than the input force. It means that the machine used my force and converted it or changed it to become bigger force. The ideal mechanical advantage that is done by any machine if there is no friction here or between the machine or between the surface and the object. Why? Because the friction force, it changed some of the energy used and converts it into thermal energy that's not calculated as work. Let's solve or see some problems on the mechanical advantage equations. We said that it equals output force over the input force. We have here a carpenter applies 525 Newton to the end of a crowbar. The force that exerted on the board is 1,575. First, we have to define which one is the input force and which one is the output force. Yes, the one that he applies, it's called the input force, and the one that the machine applies on the board, it's the output force. Then we are going to follow the steps by writing what do we know? We know the input force and the output force. And what do we need to find? We need to find the mechanical advantage of the machine. Then we are going to use the formula force or output force over the input force. The value will be 1,575 over 525. It's going to be 3. So this machine has a value more than 1 or mechanical advantage more than 1. Means that the crowbar really did a great work and saved a lot of power or energy for the man. There is no unit. Why there is no unit? Because I'm dividing two equal units over each other. Force over force, so no units. We have another one. Okay, Priya uses a nutcracker to break. Okay, and she applies, yes, a force 22 Newton on it, the force that is done on, yes, the not 66 newtons. So what's the mechanical advantage that it's used? It's going to be 3. How did she get it? From dividing the output force over the input force. Another one here. Karim applies an input force of 28 Newton to a rack, and the rack has an output force of 14 Newton. What is the mechanical advantage of it? Yes, it's going to be 0.5. Why? We are going to divide 14 over 28. So this is how we use the mechanical advantage equations, and how can we calculate it to know how many times, yes, the machine saved in my force.